Okay, right. Okay, so we will talk about it later on regarding to the test. Okay, for fluid mechanics. Okay, so yeah, for this session, right, I want to. Am I recording now? Oh yes. Okay, so right. For this session, right, we will continue with the stress and strain. Stress already covered uh, last week, right? Okay. For this session, I will talk a little bit about strain. Okay. So the topic is on the strain rosette. Okay. So we know that when we want to measure the stress cannot be measured. Okay. So how do we measure the stress? Is from the strain. Okay, strain gauge. So basically, if you look at the I'll show the pointer first. Pointer. Okay, there's a pointer. Right. So basically, when we want to test, okay, a certain point of the structure. For example, okay, this is a part of the beam. Okay, so from the bridge. Okay, so if we want to test, for example, this point, what is the normal stress and the shearing stress at this point on this element, okay, this point. Okay, so basically the strain gauge will be attached on this point, okay, at a different angle. Okay, maybe they will attach around 3, okay, to get the data, okay, so that they can calculate the strain at a different angle. Okay, so in applications, stress, we cannot measure stress directly. Okay, so we will measure the strain, okay, from the equipment, and after that we calculate the stress at that particular point. Okay, so this is how we calculate the strain of the strain of the element. Okay, so strain gauge. Okay, so strain, this is a strain gauge. Okay, so basically strain gauge you can arrange in different positions. So from there you just collect the data of the strain. Okay, collect the data, okay, from the strain gauge. Okay, so yep. Okay, so now how do we calculate the the strain? Okay, so basically from here, if we have a three strain gauge, okay, attached, okay, at certain point, okay, with different angles, okay, with different angles. Okay, so if you look at one, the strain gauge one, okay, we have a theta one and the strain one. Okay, theta two, strain two. Okay, so strain one, strain two, strain three are the strain measured from the strain gauge. Okay, measured value. Okay, so with different angle, theta one, theta two, theta three. It depends how you align. Okay, so it depends how you align it. Correct. So from there, basically, if we apply, so if we want to calculate the uh, strain x, strain y, and shear strain xy. Okay, strain x, strain y, and shear strain xy. Okay, so basically we need at least 3 strain gauge. Okay, because here we have 3 unknown, right? Strain x, strain y, and shear strain xy. So therefore we need 3 equation. Okay, 3 equation to solve the unknowns. Okay, so from there, so you just attach, okay, the strain gauge at different positions, so we know the angle is known, right? Okay, the angles are known, right? From here, theta 1, theta 2, theta 3. Okay, this is the measured value. Okay, strain 1, strain 2, and strain 3. So after we substitute into the this formula, basically we are able to calculate the strain x, strain y, and shear strain xy. Okay, so to convert to the strain x to stress x, okay, use the, if we know the Young modulus of the material, we can convert it, right? Okay, so stress over strain equals to E, right? Okay, so pretty easy. So basically we are measuring the strain and then convert to stress. Okay, this is how we calculate the strain x, strain y, and shear strain xy. Okay, so for the strain gauge, right, same as the stress. Okay, so we also, oops. Okay, so we also need to measure. Okay, so we can determine the principal strain and the maximum shearing strength as well. Okay, same as the stress. Okay, we can determine the principal strength. So what is a principal strength? So principal strength, we will have a maximum strength value and minimum strength value. Okay, normal strength. Okay, and the maximum shearing strength. Okay, these are two value, right? So how, okay, so from there, so from, if you look at this diagram, right, so we have three element. Okay, not three element, sorry, three strand gauge. Okay, three strand gauge. Strand gauge number one, right, so it's a 30-degree from the horizontal. Okay, this is the orientation, theta 1. And then strand gauge number two, okay, same, is 30-degree from the horizontal as well. But for this angle, right, so same as previous last week as mentioned, right? So if the theta angle is um, anti-clockwise, okay, anti-clockwise is considered positive value. Okay, clockwise will be considered as a negative value. If you look at this angle, right, from the horizontal to the strain gauge, is 30-degree clockwise. So therefore, for this angle theta will be negative 30. Okay, or you can rearrange to 150 also can. Right, up to you. Right, so maybe I will explain later on. Right, same thing. Okay, so for the strength gauge number 3, so it's 90-degree. Okay, with the value negative 75 micro. Okay, so micro times 10 power of negative 6 micro. Okay, so you can leave in micro. Okay, you just assume it's a symbol, it's a prefix. Okay, just leave it in micro. Right. Okay, so for this element, right, so when the strain gauge is attached at that particular point with different orientations, so you the this is the strain value that you collect from the strain gauge. Okay, so from there, so how do we determine the principal strain, the maximum and minimum normal strain, and the maximum shearing strain? Okay, so same thing. Okay, same as the stress. Okay, so now, okay, so from here, right, so how do we determine? Apply the formula, right? Just apply the formula. Okay, so from the, okay, so from this diagram, right, the from the, okay, the original diagram. Okay, from the original diagram, right, so we need to redraw again. Okay, it becomes something like this. Right, so this is original point, the first strain gauge. Okay, 30-degree theta 1. The second strain gauge, okay, will be 150. Okay, from the horizontal 150. Okay, the direction should be the same, right? Okay, so the position should remain, okay, at the same positions. Okay, if you look at these two at the same position, right? Okay, 150-degree. Okay, so from here to here is 30, right? Okay, so and then for the strain gauge number 3, okay, so will be 90-degree. Okay, so far do you have any questions regarding to the arrangements of the strain gauge? Okay, so for theta 2 you can write 150 or negative 30 also can, up to you. Any questions before I proceed? No? Yes? No? Okay, clear, right? Okay, so this is how this is the first step, right? So you need to know the theta 1, theta 2, and theta 3. Okay, so right, so the first equation is for the strain gauge number 1, right? Okay, so okay, so strain, okay, strain 1, right? Okay, strain 1 we know the value, right? So strand 1, okay, so it's 600 micro, right? Given, okay, measured, right? Value. After that, strand X, strand Y, shear strand XY, theta 1, okay, so 30 degree, you just substitute 30 degree into it, okay, you can simplify the equation. So you will obtain your first equation, okay. Same thing, right? So after that, we look at the second strain gauge, right? So from the second strain gauge, we do the same thing, right? We just substitute the value for the strain 2, okay, measured given value 450, okay. So the angle 150, you just substitute 150 into all the theta 2, okay. So after that, you just simplify. Okay, so you have a second equation, and for the third one, you would do the same thing, right? So to get the third equation, right? So for these three equation, right, you can just solve it simultaneously. Okay, so you will get this is a strand x value, strand y value, and the shear strand xy value. Okay, is it clear? So this is the step, right, to determine the strand X, strand Y, and shear strand XY. Questions? Any doubts before I proceed? No? Okay, no, good. Okay, so once we're done, right? Okay. Okay, so to calculate this, right, basically, okay, so if you look at here, right, so you need to substitute, if you solving the equation simultaneously, right, okay, you need to substitute here and there, okay, so it will be time consuming, right? So from here, okay, so basically here I have a shortcut, okay. All you need to do is just key in the value, okay, pretty fast, okay. Fully utilize your calculator. Right. So, okay. So now, right. So if you have your calculator with you, so maybe you can do it together with me. Right. Okay. So we can try it out so that you get used to it. Right. Okay. So we have these three equation, right? Okay. So these three equation. Okay. So these three equations, we can solve the unknown strand x, strand y, and strand xy by using your calculator. So how do we do it? So we just click the mode or setup. Okay, so it will appear, okay, with this screen, right? Okay, so if you have your calculator with you, okay, so if you have this screen, you just type 5, okay, click 5 to choose the equation. Okay, when you choose the equations, it will come up with this equation, right? So all the equations, right? So you can solve. Okay, okay, so for those equation, right, we choose the second one. Okay, so because x, y, z, okay, so x, okay, so strand x can represent by x, strand y can represent by y, and shear strand xy can represent by z, right? So we choose the second one, and then this d will be the value for the strand measurement. Okay, okay, so the strand 1 or strand 2 or strand 3. Okay, so okay, so we choose 2. Okay, so once you choose 2, so you come up with this matrix. Okay, all you need to do just key in those a, b, c value from here. Okay, so the first equation, a will be 0.5, b will be 0.25, c will be 0.43301, okay, and d will be 600. Okay, okay, you just can leave the mu, it's okay, because until the end, the value will be in term of mu. Okay, so should be fine, right? So all you need to do, just key in those value a, b, c, d. So you should get this. Okay, so a, b, c, d, first equation, second equation, and third equation, right? From there, okay, okay, so you just calculate. Okay, so you will get x value, okay, 725, y value negative 75, and z value will be 173.2. Okay, around that. Okay, so from there, okay, so you will get the answer. Okay, so as I mentioned here, right, strand x equals x. So from here, strand x value will be 725 micro. Okay, strand y will be negative 75 micro. and shear strength XY will be 173.21 micro. Okay, pretty easy, isn't it? Right, so it's not that hard, right? So if you fully utilize your calculator, you can do it, solve the equation, those three equations within 2-3 minutes. Okay, save a lot of time. Right. Okay, so any questions so far? Should be fine, right? Okay, so too quiet. Okay, I'm speaking alone. Right. Okay, so we move forward. Okay, now for the strength. Okay, so we also can use the Mohr circle to solve. Okay, to determine the principal strength. Okay, principal strength. Okay, and the maximum shearing strength. Okay, so how do we do that? Right. Okay, so if you have the paper or if you have your graph paper, okay, so you can do it with together with me. Right. Okay, so this is the value. Okay, so stress the strength X, and this is the strength Y, and this is shear strength XY. Okay, so from these three value, right? Okay, so first thing, how do we start to draw the Mohr circle? We need to determine the coordinate X and Y, right? Okay, so to determine the coordinate X, so it'll be strength X, comma, negative shear strength XY divided by 2. Okay, so the difference between stress and strain. Okay, for the shear strength divided by 2. Okay, the rest should be the same, right? Okay, so just let the shear strength divided by 2. Okay, shear strength XY divided by 2. Okay, so from there, okay, so 725 micro, okay, comma, minus 173.21 micro divided by 2. Okay, so this is the coordinate for X. Same as for the coordinate for Y. Right, strength Y, comma, positive. Okay, here for here, shear strength XY. Okay, so from there, okay, so substitute inside all the value. So you will get negative 75. Okay, then shear strength XY divided by 2 will be 173.21 micro divided by 2. So this is the Y coordinate. Okay, so Y coordinate. After that, we calculate the center point of the Mohr circle, right? Okay, so center point of the Mohr circle, strength X plus strength Y divided by 2. Okay, so you will have the strength, okay, the value, okay, center point from the origin, okay, from the origin. Okay, so 325 microns somewhere here. Okay, so if we have this value, then you can start to plot. Okay, so yeah, so I give you 5 minutes. Okay, so by using this value, can you plot the Mohr circle? Okay, for me. Okay, so later on I will give you the answer, then so that you can check it. Okay, so please try it. Okay, so I give you 5 minutes to try. Okay, to plot the Mohr circle for the strength. Okay, so I will get back to you with after 5 minutes. Okay, so please try. Okay, all the value are there, right? Just take out your graph paper and then use the proper scale. Okay, you can use 1 cm equals to 700 micro or something like that, right? Use a proper scale and then draw on your graph paper. Okay, so please draw. Okay, try to sketch the Mohr circle. Okay, so 5 minutes. Okay, I give you 5 minutes to complete the Mohr circle. Okay. Okay, done. Right. Okay. So we will continue. Right. So okay. So from this parameter that we obtain, okay, from our calculations. Right. So you should able to get yep, thermal circle, something like this. Right. Okay. Oops. Maybe I put wrong. Okay. Opposite. Yeah. Okay. Yeah. Okay. Yep. Should be something like this. Right. Okay. So negative 75. Okay. So this point will be y. And screen point. Okay. So this point will be y, and then this point will be x. Okay. So right. So this is the line xy. Right. So okay. So from here we are able to calculate the 2 theta p. Okay, by using by referring to this triangle. Okay, so referring to this triangle. Right. Okay. Okay. So how do we calculate the 2 theta p? Okay, so from here, okay, so moving towards the normal strand will be 2 theta p. Moving towards the vertical shear strand, so will be 2 theta s. Okay, 2 theta p and 2 theta s is 90-degree apart. Okay, 90-degree apart. Right. Okay. So from there, if we want to calculate 2 theta p, we can use this triangle. So this is okay. So the height divided by the length. Okay. So the CB. Right. Okay. So from there, okay. So we are able to calculate the value for the theta p. 2 theta p will be okay 12.22, and okay, the second theta p will be 180-degree apart. Okay, so if you don't want to calculate, you calculate the first one. After that, you calculate theta p divided by 2. Then you just calculate the second theta p by minus 90-degree. Okay, because it's 90-degree apart. Okay, if you want to plus 90-degree also can. That, okay, both will accept. Okay, both is accepted. Okay. Okay, so theta p will be a 6.11 and a negative 83.89 degrees. Okay, either. Okay, so two answer for theta p. Okay, so if you want to calculate theta s, okay, using the first theta p is 45-degree apart. Okay, so the first theta s will be negative 38.8 degrees. Okay, so the second will be 90-degree apart. Okay, okay, so will be 51.11 degree. Okay, so this is how we calculate the theta p and theta s. Okay, from the Mohr circle. Questions? Any questions regarding to Mohr circle? Okay, so if no, we will proceed. Okay, so okay, so you can refer to this triangle, just using this triangle to calculate the 2 theta p. Okay, so you can practice. Okay, so moving anti-clockwise, please do keep in mind that the 2 theta p that we calculated from here is just a magnitude, the value, okay, without a negative or positive. Okay, magnitude, right? So if we want to determine whether the theta p is a positive or negative, look at the directions. Okay, okay, the xy rotate to AB, okay, x to B, anti-clockwise, right? Anti-clockwise, so the value, the first value will be, the theta p value will be positive. Okay, so will be positive. Okay, so this is how we determine. So if the theta p is from top, okay, maybe from somewhere here towards the horizontal line, okay, clockwise, so the first value will be negative. Okay, it depends on the rotation. Okay, the rotation of the line xy. Okay, so please do keep in mind for Mohr circle, counterclockwise is a positive value. It's a positive value. Okay, the rotation counterclockwise is a positive value. Okay, so as you can see here, the 2 theta s is a clockwise, right? Okay, clockwise. So the value here is a negative value. Okay, negative 38.89 degrees. Okay, so positive and negative. Okay, shows the directions of rotation. Okay. Okay, so moving. Okay, so from this triangle, we also can calculate the R value. Okay, R value. Okay, so 2725. Okay, from here to this point, the X, and minus the stress average. Okay, so we will get the length for CB. Okay, plus the length here, the height. Okay, this value. Right, square, square root. After that, we will get the R of the Mohs circle is 409.3 micro. Okay, so based on this triangle is quite useful in Mohs circle. Right, so you need to identify this triangle to calculate the theta P and calculate the R. Right, so what is the use of R? Same as the stress. So in order to calculate the maximum strength B, at point B, so will be the stress average plus R. Okay, because CB is R, right? Okay, so stress average plus R. Okay, so so you get the value and the minimum normal strength. Okay, so from 0 to A here, from the origin to A. Okay, so will be the stress average minus R. Okay, so you will get the negative value here, this point. For, okay, so for the 84.3 micro. Okay, so come from there. And then the last.
Sorry, sir.
Yes.
Sorry for interrupting. I can't see you controlling the slide.
Huh? My slide is really.
Yeah, your slide stuck at one.
At where? My slide. Okay, let me see. Okay, okay, so are you able to see my slide now?
Yeah, it's okay now.
Okay, so I repeat again, right? Okay, so from here, we just now for the theta s is okay, right? The slide for the theta p and theta s.
Yes.
Yes, right. Okay, so we will start from here, right? Okay, so basically we can use this triangle, right, to calculate the triangle. Okay, so here to calculate the 2 theta p and 2 theta s. Okay, and then we also can use it to calculate the radius of Mohs circle. Okay, so how to calculate? Okay, so use the triangle, right? So this triangle to calculate this length, right, from here to CX. Okay, CX will be the radius, right? To calculate the CX. Okay, so based on this triangle, so we are able to calculate the radius, same as the stress. Okay, so same as the stress. Okay, so what is the use of R? We just R, okay, to calculate the strength, okay, normal strength, maximum normal strength, okay, and minimum normal strength at point B and point A. Okay, point B and point A. Okay, so we calculate the maximum and minimum normal strength. Right. To calculate the normal strength, okay, it's quite similar with the normal stress. Okay, however, for the shearing strength, okay, gamma. Okay, so if you look at the y-axis here, right? Okay, y-axis is represent gamma divided by 2, isn't it? Right. Okay, so from these points, from CD, okay, the CD will be equals to R, isn't it? The radius of Mohs circle. Okay, so the radius of Mohs circle, okay, the value of R, okay, 400, okay, and 9.3 micro equals to the shear strength maximum divided by 2. Okay, so therefore, okay, if you want to calculate the shear strength maximum, okay, will be equals to 2R. Okay, so it will be equals to, not equals to R, equals to 2R, because this value, because the value of the y-axis, okay, is represent shear strength divided by 2. Okay, is represent shear strength divided by 2. Therefore, when you want to calculate the shear strength value, you need to multiply with 2, okay, with the value that you read from the Mohs circle. Okay, so for this case, right, so all you need to do, just use the shear strength, okay, equals to 2r, so you will get the answer. Right, so this is how we calculate the normal strength and shearing strength from the Mohs circle. Okay, so any question regarding to the Mohs circle for the strand rosette? Any question regarding to the Mohs circle? No? Okay, is it clear? Clear, right? Okay, so yeah. Question. Any questions? No? Just now I hear someone is talking. No question, right? Okay, never mind. So we proceed, right? So this is about the strand rosette, right? The step most likely same as the Mohs circle for stress. Okay, here the strand rosette. Okay, so if you follow the step, okay, so what I teach here, so you should able to calculate all the value. Okay, shouldn't be a problem, right? So if you follow the step, okay, it won't take too long to calculate, because okay, so to calculate the strand x, strand y, and shear strand xy, okay, so just key in into your calculator, okay, let the calculator do the job for you. Okay, so from there, just determine the coordinate of x, y, and then average, stress average. After that, you can start sketch your Mohs circle. Okay, so the scale for the x-axis and y-axis must be the same. You cannot use the scale. The scale for the x-axis is 1 equals to 10 micron, or for example, and then the y is 1 equals to 5 micron. Okay, if you do like that, you won't draw a circle. You will draw an ellipse. So, for example, okay, you won't draw a perfect circle. Okay, from your graph paper. Okay, if you use different scale for x and y axis. Okay. Okay, so yeah. Okay, so if no, right? So I have a task for you. Okay, not now, right? So okay, right? So you there is one question, right? This is a partial question, right? Okay, partial question. Okay, so I think it's on the discussion board as well, right? Okay, partial questions. Right. So from this past question, right, what you need to do, right? So you try to answer these questions. Okay. No need to discuss with your friend, but you can view this video later on, okay, to assist you to solve the problem, right? So all you need to, I just want you to practice on how to draw the Mohs circle for the strand rosette. Okay. So okay, so for this question, right, okay, so you can refer to the discussion board, or you can go to the module. Okay, so Canvas module week 9, and then there's a assignment. Okay, I create an assignment, but it's 0 marks. Okay, no marks. Okay, it's up to you. You want to submit, you submit. If you don't want to submit, it's up to you, right? So it doesn't really matter, right? So but it's good for you to try it out, so that if I have time, I just go and view and check it, and then maybe I will leave some comments, okay, for your solution. Okay, so I encourage you to do it, not copy from your friend, because there is no marks. Okay, not like the assignment. I know some, okay, it's too obvious for some student, right? They copy the assignment. They really trust their friend even though the answer is wrong, and then the solution is wrong. Okay, so never mind. So I don't want to talk about it, since we already go through the second assignment, right? So just do me a favor. Okay, so I think the assignment is open already, right? So you can just go there, and then if you have a free time, okay, try to solve these questions, and then upload your solutions. The link will open until Sunday, I think so. Okay, by this Sunday. Okay. by this Sunday, right? It will close, right? Okay, so the yeah, just feel free to try it out. Okay, so no marks. Okay, no worries. You won't get any marks deducted from this question. Just want you to try it out, right? And then so that, because I know if you try on the discussion board, it's very shy for you to post your answer there. Okay, so maybe I create a platform for you, okay, to show your answer to me, and then maybe I have a check and then give you a comment for the improvement, right? Okay, so this is a task, okay, for this week, right? Okay, so for next week we still have, because next week next Thursday, let me check first. Next Thursday is on 28th. Yeah, 28th we still have one live discussion, okay, on the topic. I think it's failure theory. I think so. Yep, failure theory. Okay, so we talk about failure theory first. Okay, so Tresca and von Mises theory. Okay, so that. Okay, so on 28th we will have one live discussion session. On the 4th of June, okay, maybe we have a rest. Okay, because I checked the schedule with my other colleagues, so they will conduct a test for the fluid mechanics one. Okay, so on the 4th we will take a rest, and then we'll come back again on 11. Okay, so this is my plan, okay, for our live discussions. Okay, but however, from time to time you can email me. Okay, so if you solve the problem, you have any difficulty regarding to the topics, questions, doubts, feel free to drop me an email, or Tiong. Okay, so another lecturer, okay, so who can assist you in this unit, right? Okay, so don't be shy to try it out, right? Okay, so I know for this semester, I think the passing rate is 100% for sure, because I went and marked the test paper and then the assignment. I feel like it's most likely all students will pass. Okay, so however, okay, so for the lab report, okay, so lab report, please prepare your lab report, because the lab report will be due on 5th June, isn't it? Right. Okay, so you can start write your lab report. Okay, so it's an individual report, and I think is the link open? If not open, I will check again. Okay, I will try to open the link for you to submit your lab report. Okay, so yep, and the due date is on 5th of June. Okay, so lab submission will not be accepted. Okay, same thing, right? Okay, so do you have any other questions regarding to this unit? Okay, any questions you want to ask? We only have to submit the lab sheets. Wait, huh? You just submit your lab report, isn't it? So you just prepare. No, you cannot submit your lab sheets only, right? You need to create your own lab report, Sajid. Okay, so the guideline is there, right? So if you view the slide, okay, so the guideline of the lab report is listed. Okay, are listed, right? The guideline. Okay, so okay, so the topic, subtopic, the type, okay, everything, right? So you need to check according to the guideline. Okay, so prepare your lab report. It's very easy to score. Okay, so you know, for the lab report, basically you will get 8 or 9 marks out of 10. Okay, so unless you didn't submit, unless you didn't do it. Okay, yeah, questions, any question regarding to the assessment, questions to the topics? Okay, so before we end our live discussion for the lab 2, huh? For lab 2, up to you. For lab 2, you can use 0.7 L or 1 square root of 2 L. Up to you. Not
So,
much different. Yeah.
is there a third assignment?
Third assignment, yes. There will be a third assignment by, I think, by this weekend. I'll load it by this weekend. Yeah. Okay, so
Alright.
so because I think for the assignment, because every time I upload too early, but when I look at the submission, most likely the student will submit during the last few hours. Okay, maybe they're waiting for their friends answer. Okay, so pass it to one, pass A, pass to B, B pass to C, C pass to D, and so on. Okay, so yeah, when so if you want to copy, you need to ensure if for example, right? So because it's too obvious, because when I mark the paper, right? If for example question one part A is wrong, okay, so I figure out some student when they do a mistake, because the mistake is something like it's impossible for the the same person to do the same mistake. Okay, however,